So today we have an interesting trigonometric equation that you can see on the screen. Now the question over here is to find the value of x in the first quadrant that will satisfy this equation. So this is Anmol Mishra, and now let us see the solution. How can we find the value of x? So first of all, I will start the solution by giving the value x some boundaries. So as it has been given that it is in the first quadrant, this means x belongs to 0, 90 degrees, or we can say x belongs to 0, pi by 2. This means whatever value of x we get, that should be in this particular range. Okay. So now the equation we have is sine cube of x plus sine of x upon 2 equals to cos of x. So now to solve this particular equation, what I will do is I will simply take a right angle triangle. A triangle that is having one of its angle as 90 degrees. Now to make this right angle triangle a special triangle, I will take one of its angle as the variable x that we need to find. The height of this triangle as a variable a, the base as equals to b, and the hypotenuse as h. So now I have taken a right angle triangle with the angle x that we need to find. Okay. So now in this right angle triangle, the value for tan of x, that is just a ratio, would be equals to a upon b, opposite upon the base. It's all trigonometric ratio, you should know. Now in the same right angle triangle, the value for sine of x would be equals to a upon h, that is opposite upon the hypotenuse. And in the same right angle triangle, the value for cos of x would be equals to b upon h. So from this right angle triangle, we got the value for all the three trigonometric ratios: tan x, sine x, and cos x. Now recall the original equation, that was sine cube of x plus sine x upon 2 equals to cos of x. So in this equation, I will replace these trigonometric ratios with the value that we have just got, that is a upon h and b upon h. So the first term is sine cube of x, so it can be written as a upon h, the complete cube, that is the value for sine x, plus sine x upon 2, therefore a upon h upon 2 equals to cos of x, that is equals to b upon h, that is present over here. So now let us simplify this thing. So now I can just simplify a upon h upon 2, and it can be written as a upon 2 times h. Okay. Now remember that this triangle over here is a right angle triangle. This means we can use the Pythagoras theorem. So by using the Pythagoras theorem in this right angle triangles with variables a, b, and h, we get the height square plus the base square equals to hypotenuse square. So here we have a relation between a, b, and h using the Pythagoras theorem. Keep this also as the equation number 1. So now here we have the original equation that we need to simplify. So first of all, I can see that I can take a upon h common. So inside the bracket, I will have a square upon h square plus 1 upon 2, and this thing is b upon h. Now h and h can be cancelled out. So what we get is a into a square upon h square plus 1 upon 2. I can take the LCM, so I will get 2a square plus h square upon 2h square, and this thing is equals to b. Now I can do the cross multiplication of 2h square on the other side. So on the left hand side, I will get a into 2a square plus h square equals to 2h square into b. Okay. Now recall the first equation. Here we can see that we have the value for h square in terms of a and b. So here the equation that we just have, in this we have one h square over here and the other h square over there. So this 2h square I will replace with its value that we have in the equation number 1. So using that, I will get a multiplied with 2a square plus, now instead of h square I will write a square plus b square. This is equals to 2 times b multiplied with a square plus b square, the value for h square. So inside this bracket, I can see 2a square plus b square will turn out to be 3a square plus b square. Now on both of the side, I need to simply open the brackets. So on the left hand side, I will have 3a cube plus ab square, and this thing is equals to 2ba square plus 2b cube. Okay. Now I will simply shift these two terms from the right hand side to the left hand side. So they will turn out to be negative, and this equation would be equals to 0. Okay. Now I will do some kind of modifications. 3a cube, I will write it as it is. Now instead of negative 2b cube, I will split it as negative 3b cube and plus b cube. You can see that simplifying this both will give me negative 2b cube. No change. Plus ab square as it is. Now instead of negative 2 times ba square, I will write it as negative ba square, and this thing is equals to 0. This term directly split as negative negative, and negative 2b cube as negative 3b cube plus b cube. Okay. Now from this both I can take 3 common, so inside the bracket a cube minus b cube. From this both I can take negative ab common, so inside the bracket a minus b. From this 2 I can take negative b common, so inside the bracket a square minus b square, and this thing is equals to 0. So now we have this particular equation over here, and it's time to use the identities now. So remember the identity for a cube minus b cube, that is a minus b multiplied with a square plus b square plus ab. Okay, and similarly the identity for a square minus b square is a minus b multiplied with a plus b. So these two identities I will utilize in this bracket over here and this bracket over there. So the first bracket will turn out to be 3 multiplied with a minus b multiplied with a square plus b square plus ab. Negative ab multiplied with a minus b as it is, and at the last negative b multiplied with a square minus b square will turn out to be a minus b into a plus b. The first and the last bracket I use the identity to open it a little bit. Now from all these 3 terms I can take a minus b common. So a minus b taken common, so inside the bracket I get 3 into a square plus b square plus ab minus ab negative b multiplied with a plus b, and this thing is equals to 0. So now I can see that we have 2 factors and multiplication of them is giving us the result as equals to 0. So either this factor is 0 or either this factor is 0. So let us see the first case in which we take a minus b as equals to 0, and this thing over here can be anything. So if a minus b is equals to 0, we get a equals to b. Okay. Now let us see the second case in which we equate this as equals to 0 and assuming that a minus b can be anything. Okay. So 3 into a square plus b square plus ab will turn out to be 3a square plus 3b square plus 3ab. Negative ab as it is, and opening the last bracket will give me negative ab again and negative b square, and this thing I equate it as 0. Now simplifying this thing, so 3a square plus 3b square minus b square becomes plus 2b square. 3ab minus ab becomes positive ab, and this thing is equals to 0. Okay, so now we have this thing, and this thing is not true. Why? Because a and b were sides of a triangle. So first of all, they cannot be equals to 0. If they are 0, the trigonometric ratios will be not defined. Remember, it was a trigonometric equation. And they cannot also be negative. So what we get is a comma b belongs to the real number except 0 and only positive real numbers. So these are the parameters for a and b. And for this particular parameter, this equation can never give us 0. So this equation is not true. So we have to go with only this case where a minus b we equated as 0. So we got a equals to b. So remember the triangle. This was the right angle triangle. And in this triangle what we have just got is a equals to b. So let me just replace one of these variables. So here I will simply replace the value b with its value that we have got as a. So look carefully, we have a right angle triangle. 2 of its sides is equal. This means the bottom 2 angles become equal. One of the angle is already x, so the other also become x. So in the right angle triangle means it's a simple triangle. We can use the angle sum property. So 90 degree plus x equals to 180 degree. And simplifying this thing will give me x as equals to 45 degree. And that's the answer that we were looking for. You can even do it like this way. The value for tan of x previously was a upon b. Putting b as equals to a, we get a and a got to cancel out. Tan x as equals to 1, and we know that x equals to 45 degree gives the value for tangent as 1. So the same thing we will get. And what if the first quadrant was not there, means just find the value for x. So in that case, this method for the triangle summation of angles would not work. We have to go with trigonometric comparison only, because the trigonometric functions are periodic, and in that case we will get the value for x as n pi plus 45 degree. Let me write it in radians only. N pi plus pi by 4, where n is any integer. So for any case means in general the value for x would be this thing, and in our question the value for x is 45 degree, or we can say pi by 4. So this was my way to solve this particular question. If you have any other method other than this, or else if you have any other question that you think I should try, you can do comment below, and if it's hard to comment, you can email me, or else you can send it to me on my Instagram. The link is in the description.